Hi, I'm Bharath from Group 10. My other team members are Dhananjayan, Joel, and Vamsi. We have developed an Android application for our CSE 535 mobile computing project. We named our app Sherlock. Our idea was inspired from a Kaggle problem where the goal was to identify if a particular set of data is from a particular device. The dataset provided for the problem consisted of accelerometer data collected from various users using an application called QuickDraw. Basically, a set of users were asked to use this QuickDraw app. The accelerometer data was recorded during the usage of the app, and that formed the training set for the problem. The goal of our project is to identify the legitimate user of a mobile device using the accelerometer data and alert the user in case we observe any anomalous behavior. The very first thing a user has to do once he installs the app is sign up. Now, Vamsi will sign up with his account details. So he's entering his email ID, which is by the way, all fields are mandatory in our application. He's entering his primary contact number and his emergency contact number. Now, when he presses sign up, we validate all the fields and we create an account for Vamsi. Now, Vamsi is successfully registered with Sherlock. Now, he's going to log into the application with his username and password. For security reasons, when Vamsi enters the password, we use MD5 hash encryption on the password and send it to the cloud. And in the cloud, we compare the hash value of the password which is already present in the database to validate if Vamsi is the legitimate user. Successful login, you'll be directed to the dashboard page. The user will be provided with various options such as update user profile, logout, about Sherlock, and start and stop accelerometer recording functionalities. The update your profile activity contains the following. The user will be given options to change the password, primary phone, or emergency contact number. Now Vamsi is changing his primary phone number to the number he's typing. Once he clicks update, there will be a toast message saying update is successful and you'll be directed to the dashboard page again. The start accelerometer recording functionality is used to collect accelerometer data at a particular frequency and periodically send it to the cloud. When the button is pressed, a background service is triggered to collect data from the phone. The accelerometer sensor is registered and it collects data at a frequency of 1 Hz and saves it in a SQLite database. Each row in the database table will have a timestamp, X, Y, and Z coordinates of the accelerometer's values associated with it. We collect 300 such data entries and send the batch of values periodically along with the GPS coordinates that includes latitude, longitude, and the name of the city where the device is present currently for the training of ML model and prediction of anomalous activity and alert system. The stop recording functionality is used to unregister the accelerometer listener so that the device will stop collecting accelerometer values and stop storing it in the database. So each action such as register, login, update user profile, and sending data for training and testing from the application to the cloud is handled through REST calls. On the cloud, we have a Flask application which is hosted on the Apache server. Each of these endpoints accept JSON data and we validate and enter the data into the respective tables in MySQL. Upon correct execution of function calls, we send the appropriate response for these calls. The application takes control from the cloud and continues the appropriate activity. We are going to show a quick walkthrough of the available endpoints and how data is being processed. The register user profile takes in all the details which we showed earlier and validates them if there is an entry or not. If there is no entry, it creates a new user. The auth login checks for user details in the DB and authenticates if the user has entered the correct username and password. Upon successful login, it will send out a positive response back to the device. When update your profile is pressed on the device, the data that needs to be updated, such as password, primary phone number, or secondary contact information, is sent as an JSON object. It is now validated in the cloud endpoint, and the appropriate fields are updated in the database. Similarly, there are other endpoints to collect accelerometer and GPS data for training and prediction purposes. So now we dive into the core of our application, that is the machine learning model. So now Vamsi has slyly taken Joel's phone and is going to play a game while Joel is working on the project in his laptop. I'll explain our model while Vamsi is playing the game and the application is collecting data to be sent for prediction and alert purposes. As we mentioned earlier, the data set for our ML model is from the accelerometer sensors. Each data point has 900 features, which is the accelerometer data collected at a frequency of 1 Hz and sent from the mobile device at a regular interval of 5 minutes. Since there will be 300 data points and each data point will have a XYZ values associated with it, we'll have 300 into 3, that is 900 features that will make up a single data point for our in our training data set. The class label associated with each data point will be the email ID of the user using which the user has logged in into a particular device. For the purpose of the demo, we have about 4,100 data points collected from over 7 users. Uh, Out of these 7 users, 5 of them are from Kaggle, so we collected data sets from the training data set available in Kaggle, and the other 2 are from Joel and Dana's devices. They both have distinct patterns of mobile usage, and we have used theirs along with the Kaggle users for the purpose of the demo. Based on recent research and the results we saw from the assignments, we chose to use support vector machine as our ML prediction algorithm. We experimented with different kernels like linear, polynomial, and RBF kernels, and we found RBF kernel to be the best suited for our application based on the results we got from five-fold cross validation over the training data set we have. The decision boundary hyperplanes that are generated after the training are saved in the cloud, using which prediction will be done. We predict if the user is legitimate based on the decision boundary thus saved. We save the decision boundary in the cloud itself for security reasons. For instance, if it is saved in the mobile device, attacker could easily get to know the decision boundary and break into the system. Moreover, as more and more users start signing up with our application, the decision boundary would become too complex and too heavy for it to be saved on a smartphone device. So if the predicted class of the user ID mismatched uh, with that of the user who's using the phone, uh, we will shoot an email to the user about the same with the GPS coordinates from the device where it is currently located. So Vamsi is still enjoying his game while the app is just about to do the prediction and send out the results. Let's wait to see what the app has in store for us. And yeah, the app has predicted that Joel is not the one who's using his phone. We got an alert as Vamsi's usage pattern is distinctly different from that of Joel's. Now, Joel, who's working on his laptop, can come and rescue his phone from Vamsi. So now that Joel has got his phone back successfully, let's conclude it our demo. So basically training can be done in discrete intervals. Suppose a new user signs up, the user data is collected for training purposes and not used for prediction until the training is done for the new batch of records that are inserted after the last training run. So from this point, after the next training is run and a new set of hyper planes are created, If the user sends data, it will be used for prediction of anomalous behavior and not for training. Suppose a new user signs up, the data he sends will be temporarily stored meanwhile until the next training is done. So the K-fold cross-validation accuracy for our model is around 61% for now for 7 users. We researched about the Google Awareness APIs and it fits to our application. The framework is oriented more towards giving the details about the context of the user rather than the sensor data directly. The API was giving info such as walking, driving, etc. We are planning to use mobile sensor data fusion to improve the accuracy of the sensor data. However, since we had only the accelerometer data, we did not have the necessity to do sensor data fusion. So we have basically completed all the tasks that we had mentioned in the project proposal, and we have actually covered a few extra tasks such as material design for UI and K-fold cross validation and etc. So thank you